Uniform circular motion is motion in a circle that happens at a constant speed. Imagine that you have a bowling ball, and that bowling ball is travelling through space or on the ground, rolling across the ground at some speed in a straight line. What would you have to do to that bowling ball in order to change its path, to get it to turn, to get it to move in a circle instead of a straight line? Yeah, you'd need to give it a little tap from the side with a hammer. You'd need to apply a force, which we're going to call a centripetal force. It's just provided by a push force, say from a hammer. And so a moment later, the bowling ball would be here, and its speed now, or its velocity, would be in that direction. And again, if we kept tapping the bowling ball towards the centre of the circle, we'd actually find that that bowling ball would go around and around. And so that is what is required to create circular motion. A force directed towards the centre of the motion, towards the centre of the circle, needs to be applied in order to get that object to move in a circle. And that's always the case. Circular motion requires a force directed towards the centre of the circle. And another way of saying that is the force is essentially always going to be perpendicular to the direction of motion. Let's approach this a little more mathematically. I'm going to label this first vector for velocity vi, so the initial velocity, and this one here, the final velocity. Now we know that if we wanted to calculate the acceleration, it would just be the change in velocity over the time elapsed. Note here that the size of that velocity, so the speed, isn't changing, but its direction is, and so we still have acceleration, because acceleration is a vector. So I'm just going to have a look at that change in velocity calculation there. That is the final velocity minus the initial velocity. And a little trick that I like to use when using vectors is that I don't like subtracting vectors, but I can add vectors. I can say the final velocity added to the negative of the initial velocity, and then I can do a vector addition using a diagram to show what that resultant change in velocity will be. And so I'm going to carefully draw this vector addition here. I'm going to start with my final velocity, label that VF, and then I'm going to add the negative of the initial velocity, and that just means I need to turn that initial vector, the initial velocity vector, around. So it's going to be something like this, and it will be the same length. So there's my negative VI, so I'm going to add them together. And when I add two vectors together, I just need to add, my final vector goes from the end of the first to the tip of the second, and so that is my change in velocity. And if I map that change in velocity and put it back over in my diagram here, and of course this is difficult to draw because we are talking about changes that happen over an infinitesimal period of time. I've just kind of stretched it out a bit. So I'm just going to draw that in the middle. It's going about that direction. And so my change in velocity is headed towards the center of the circle. So if my change in velocity points towards the center of the circle, that means I can calculate now, or determine, which direction my acceleration is going. And because I know that acceleration is the change in velocity over time, and time is a scalar, it doesn't have a direction. So that means the direction of my acceleration vector is the same as the direction of my change in velocity vector, which means that my acceleration is also directed towards the center of the circle. And because I know that force equals mass times acceleration, if my acceleration is heading towards the center of the circle, my force is also heading towards the center of the circle. I'm just going to move these notes up a little. The force that provides circular motion, or allows circular motion to happen, has a special name. It's called centripetal force. It's important to note that centripetal force isn't a special new force. It can be provided by any other type of force. So it could be provided by friction. It could be provided by gravity. It could be provided by an electrical or magnetic force. And I'll summarize some of those examples in the next video.